All right, hello people watching this. This is 2-2. We are almost to the fun part, which is 2-3, but we're going to finish the notes today. We're on example 5. And yesterday we did stuff with this equation, like this exact limit thing, except the only difference is now they're using t instead of x, which is the same thing. It doesn't really matter. Because now instead of calling this the derivative, they're calling it velocity. But we know that derivative, velocity means the same thing as finding the derivative, okay? It also is the same thing as like the instantaneous rate of change. A derivative is a slope of the tangent line. All of these things mean the same thing. Derivative is slope of tangent line, which is another way of saying velocity, which is another way of saying instantaneous rate of change. It all means that. In section 2-3, we're going to learn easy ways to find derivatives, but for now we have the limit process, which is kind of icky, but we'll get through it. It'll be okay. These two parts that are on the top here, f of t and f of t plus h, this just means you're plugging t plus h into your equation. You're plugging t into your equation, okay? So down here in example 5, we have the position function of a particle. So this is what's happening. This is a, what does that look like if you graph it? It's a quadratic and it's negative. It's negative t squared. So it is a parabola that's going like this, right? And we don't really have to look at this backside because that would be like negative time. So we're kicking a particle off of a cliff or something and then it is falling in a parabolic motion type of thing, okay? All right. And they want us to find the velocity function. Okay, so they don't want a specific velocity at a certain time. They want the velocity function. So we're going to just find the derivative using this limit process. Okay, here we go. The limit as h goes to 0 of f of t plus h. Okay, f of t plus h. I'm going to start writing f of x, which is 1 plus 5t. But instead of t, I have t plus h minus 2 times t plus h squared. That's my f of t plus h function. Got it? Questions about that? Okay, then I do minus this guy, which is f of t. So it's 1 plus 5t minus 2t squared. That's just my original f of t function. All right, all over h. So I have my two functions here, this guy and this guy. This one I've plugged in t plus h here. This one I've just left alone, and he's the same function. Okay? And now we got to do lots of simplifying. Boo. Boo.
Why didn't we just have it as 1 plus 5th in the first place? We have the minus 2t squared.
Yeah, this whole thing is right here.
I didn't write that in there.
Ah, there you go. Okay. All right, so let's do some simplifying. So I have on the top, I have 1 plus, let's distribute our 5 through. So we got 5t plus 5h. All right. Then we need to FOIL this guy. I'm going to FOIL him up here. So we have t plus h times another t plus h. Okay. So t times t is t squared plus th plus another th plus h squared. Blah. All right. So my middle two pieces, that can be 2th. Whew, are we doing okay so far? Am I going too fast? Okay, now, what do I do with that? I have to distribute the negative 2 through. So negative 2 times t squared, negative 2 times 2th is negative 4th, and negative 2 times h squared is negative 2h squared. That was that big jumbled mess. That's just this chunk. But things are going to cancel out really nice and pretty for us, I hope. Now distribute our negative through. So minus 1 minus 5t plus 2t squared. Oh, baby. All over h. Oh, baby. Here we go. All right, are we good? Are we good so far before we start to cancel? Okay. All right, so 1 minus 1. Gone. Yes, we FOILed everything and we did all of the things and distributed the negatives and all that stuff, okay? Now we've got 5t minus 5t. He cancels. Negative 2t squared plus 2t squared. So we only have 3 terms on the top. That's exciting. Let's write what we have. 5h minus 4th minus 2h squared. all over, whoa, all over h. Okay, that's what we have left over after we cancel everything. All right.
Pull an H out of?
Can we pull an h out of the top? Yeah, we're gonna. So let's pull an h out of the top. And we are left with 5 minus 4t minus 2h. He'll still have an h, right?
Yeah.
Okay, and then what? Cancel your h's.
Yeah.
All right, then what?
Then
Now we can do the limit as h goes to 0. All right, of 5 minus 4t minus 2h. Okay? And what is that now? What do we do? Plug 0 in for h, right? 0 goes here. Okay? So negative 2 times 0 goes away, so I'm left with 5 minus 4t. Okay, what does this thing do for me? That's my final answer, but what is that thing?
plug in your t, and that gives you.
That is the function for velocity. Wait a second. I thought velocity should be a number. Like, isn't velocity like a speed?
You can plug anything in.
Yeah, so I would have to say I want to know the velocity at 6 seconds. I want to know the velocity at 12 seconds. I want to know the velocity at 1 second, right? And then I could plug in that number in for t and get an answer, right? For the velocity. That just tells me what he's doing, okay? Makes sense? Good, good? That was a lot. All right, again, we'll get to the point where I can just tell you from this function the derivative is negative 4t plus 5. Is that right? Negative 4t plus 5? Yeah, boo. Boo, boo, boo. Okay?
Hang on, wait, stop, wait.
Oh yeah.
That's the power rule. Yep, we'll get to the power rule. Can you guys see that from the power rule?
So h, 5 minus 4t minus 2h.
Yeah, this is a bridge between. I know they're like, we don't buy anything that she says about this whole needing limit
This
thing.
is what she says about
This is what I say
Hang on, minus
because it's there. Whatever. Okay. Good?
Sure.
Okay. Let's talk 2 more things. Let's talk continuous. Put this off to the side of your notes. Continuous. Okay? All right. 3 things we talked about in the last chapter. 3 things can make a function not continuous. What are they?
A whole,
A whole,
va,
a va,
and a piecewise.
I should do va, and a piecewise, I'm going to say piecewise gap. Okay, a whole, a va, and a piecewise gap. Now, not every piecewise function is discontinuous, only if like the 2 have a gap. So like if he has something like this and this, let me go the other direction, and like this, then he's fine. Right? Like if we have a piecewise function where the 2 come together, but if he does this instead, then that would be bad. Like we have a gap, okay? So that's not continuous. Now, if it's continuous, it has to be continuous in order to be differentiable. Do you see this word right here? People think I make this word up. I said this one year in calculus and they're like, you made that word up. I did not. Differentiability. Differentiability means can find the derivative. Okay, if it's differentiable, that means you can find the derivative. Differentiable means you can find the derivative. Okay, so you can't find the derivative if it's not continuous. If it has a whole, a gap, or a va, it's not going to be continuous. You can't find the derivative at that point because it doesn't exist. The point doesn't exist. Now, if it is continuous, doesn't necessarily mean you can find the derivative. These are 2 places that are continuous that you can't find the derivative. And they are at corner points. This is called a cuspid, where he comes to a tip. You remember cuspids?
You're making this up.
I'm not making this up. I'm not making this up. That's a cuspid, right?
You're just playing.
No, don't lie.
Yes.
No.
Technically it is. Yeah. Yeah, see? Ha. Meh.
You do
Oh.
Wait, hold on.
Okay.
No, you know what you're doing? You're
So-
playing like a whole like
She's
You're
gaslighting
like
us all.
4-year-long prank on us that you're making all these words up and teaching us wrong math, and then we're going to get to college and say these words.
That is my
That's not
goal
true.
in life, to teach you everything
to
wrong. I
gaslight
told
us?
myself, no, I told myself I was going to do that with my children. Like,
You're
have you
gonna
ever heard?
gaslight your children.
No, I told myself that when I still have time, there's still time with Navy, I could still do this. That like teach her that a pencil sharpener is like a snarfler or something. Like the name of this device is called a snarfler.
No.
So when she goes to kindergarten and she asks her teacher, "Can I go snarfle my pencil?" Everybody laughs. I would love it. Totally gaslight her into thinking that is called a pencil snarfler, right? Can I go snarfle my pencil? Wouldn't that be so funny?
Your kid would come
Oh,
bawling.
come on.
Yeah.
You're going to the retirement home.
What?
Yeah, she's gonna send you to the retirement home.
Right. Yeah. They would hit you. You can't get it? Okay. Okay. All right. So this is my last point. Okay. So just because it's continuous doesn't mean you can find the derivative. So for this example, this is continuous. Yes. Yes, continuous. But no derivative here. Zoop. I can't find the derivative at that point. I can find the derivative at other points along the curve, but not at that cuspid point because it comes to a tip. I can't find the derivative at that point, right? So he is continuous, but you can't find the derivative at that point, okay? Same thing here where it has a vertical tangent line. At this point, this is called a point of inflection. You guys have heard that before, maybe? Have you heard of a POI before, maybe? You trig kids probably haven't because we talk about it in trig. So a point of inflection, you cannot find a derivative at a point of inflection because it has a vertical tangent line. And vertical tangent lines don't exist because they're not functional. So this is, yes, continuous, but no derivative. I can find the derivative, like let's say here, I could find the slope of the tangent line at this point right here, okay? But I can't find it at that vertical tangent line point, okay? So he will have derivatives other places along that curve, but not at that exact point, okay? So just because he's continuous doesn't mean I can take the derivative at every place, okay? He has to be continuous in order to be able to take the derivative, right? But just because he's continuous doesn't mean I can, right? Does that make sense? It's kind of like the whole every square is a rectangle, but not every rectangle is a square. Just because he's continuous doesn't mean he's differentiable, but if he's differentiable, that means he is continuous, right? Yeah. Anyway, something like that, okay? All right, let's go down to, are you done writing? Can we go to the bottom? Warning. A function may be continuous at a point, but not differentiable at that point. We just said that, right? Just because it's continuous doesn't mean he can find the derivative, okay? And then we have something called one-sided derivative. So at an end point, you can only look at the derivative or the limit from that side, okay? Or the slope of the tangent line from that side. If you're at an end point on the right side, we can only look at the slope of the tangent line from the left side, right? It's kind of like finding the left and right hand limits if you have end points, okay? So there is how that works. So I don't think we have an example for that, but that's just how that works, okay? Good? Questions? Ooh, that's all I have. Let's get on to 2-3 sometime next week. Okay? That is it.
Okay.
All right. Goodbye, people watching the video.